Okay, I think I can start now. Okay, so for everyone here, hello. This is the first lecture in SPI's ZCO lecture series, right? This one isn't gonna cover any like big topic or anything. It's mainly just gonna serve as an introduction to like competitive programming because I know that a lot of people here are new and this is their first time doing it. So yeah, I thought it would be a nice idea to have something like this. So before I get started, I just want to confirm that everyone can hear me clearly
Yeah,
and
yeah,
that
perfect.
everything's working properly. Yeah, okay, great. There's no lag or anything, right? Okay, cool. Quick notes. What I'm gonna say in this lecture will generally apply to competitive programming as a whole, but obviously there will be sections of it that will focus specifically on ICO because that's what we're preparing for. Right now we're preparing for ZCO, right? Our main aim is to qualify through ZCO and get to INOI so that we can give INOI. Uh, Fortunately, with just like a few months of preparation, I think this is like pretty easy to do. So you don't have to stress out too much. Um, to begin with, of course, every single competitive programmer, first step you need to do is choose a programming language, right? So there are three main options that people generally go with. I mean, the most popular one by far is Python. Then there's Java, then there's C++. So the reasons why Python is the most popular is, I mean, it's the easiest to learn syntax wise. Java is taught in school. However, in competitive programming, C++ is actually used the most. Now, the reason for this is because C++ is actually a lot faster than Python at like almost everything. In some cases, it can be even more than like 2 to 3 times faster. Specifically for you guys, INOI does not allow any language other than C++ to be used. Okay, so I know that a lot of people here will maybe be like using languages other than C++ and probably just because it's like convenient to use, right? Which I mean, I totally get. But I think one of the first things you should do, like while starting, is just transition to only using C++. The reason is because this will help you a lot in the future. I mean, eventually, when you give INOI, you will thank yourself now for doing that. Moreover, like that's the that's the first reason, right? The second thing is that any tutorial or blog or anything you'll find online mostly is going to be written in C++, and it will assume that you know C++. So I hope everyone here, I mean, I hope everyone here understood that you're going to have to start learning C++. Okay, so SPUI, all of the future lectures, including this one, I mean, will also use examples in C++. If you aren't familiar with it yet, that's totally fine as well because, like I said, we just have like one or two code snippets in this lecture. Everything else is just going to be like tips and tricks. So that's totally fine. Okay, but even then, like I said, good idea to start learning C++ as soon as possible. Okay, cool. So I hope that's clear. The next thing I want to cover, this is also like something really important, is how contests work. Now, people who have been people who are coming to CP for the first time will probably not know this, right? So there's two major types of contests. There's ICPC style contests and IOI style contests. Okay, so for example, ZCO follows it leans towards IOI style, whereas Code Forces contests lean towards ICPC style. Uh, Now, you need to keep in mind that these two types of contests are really different from each other. Um, ZCO is shorter than ZCO is generally shorter than the general duration for most IOI style contests. It's like 2 hours long. Most IOI style contests are 5 hours long. One very important point about ZCO is that the time at which you submit a solution doesn't matter. Now, like I said before, some people are new, haven't done Code Forces contest before. That's fine. Maybe some of you have, and it's pretty common knowledge for those who have that. I mean, if you submit like a div 2A first, 5 minutes in, then a div 2B 15 minutes in, then div 2C like maybe like 30 minutes in, that's gonna give you pretty decent performance, right? But if you submit all three of them, say 1 or 2 hours in, or you solve like the third problem, like right as the contest is about to get over, you're probably gonna lose rating. I mean, my point is that the time at which you submit it matters a lot in code forces. In OI, most contests, I think all contests that you will be giving in OI, the time doesn't matter at all. That means a submission you make for like a 30-point subtask, 5 minutes in, will have the exact same weightage as a submission that's made like 5 minutes right before the contest is about to end. It's not even used as a tiebreaker. Like if you have the same score, you tie. There's no time used at all. Okay. So now I mentioned this first because I felt like it is pretty important. Maybe not specifically for the time reason, but just to make you realize that they are different contests. Like fundamentally, IOI and ICPC style contests are very different. Okay, so this is a pretty big difference. So I thought I would mention it first. Anyway, so technically, like the definition of a contest is that it's a set of problems. You're given a definite amount of time to solve it, and you need to try to solve as many as you can. One more difference between IOI style and ICPC style contests is that IOI contests have 3 problems, generally speaking. These 3 problems are each comprised of subtasks. So that means that you may have a subtask that's like worth 20 points, which will be an easier version of the full solve. Then maybe you'll have a next subtask that's 30 points, which is like builds up on the second, builds up on the thing you just solved, and then you'll finally have 100 points. Again, for people who have given code forces contests, it's not like that, right? You either get wrong answer or AC. So you either get all of the 100 points, you fully solve the problem, or you don't. Another difference is that IOI style contests generally have around like 3 problems, and ICPC style have a lot more. Like for example, code forces contests have like 5 to 6, and ICPC itself, if I recall correctly, has around 10 to 12 problems. Okay, now some technicalities. I already mentioned ZCO has, or maybe I didn't mention this, but ZCO has 2 problems and 3 hours to solve them. Subtasks. INOI, on the other hand, has 3 problems and 3 hours. IOITC, that is, if you qualify through INOI for like the training camp, the top 30, they're gonna have 3 days of contests. Each one of these days is going to have 3 problems, and you're given 5 hours to solve them. So this 5-hour thing is the actual exact IOI format, by the way. Okay, any questions regarding the types of contests so far?
Yeah, so just for ZCO, I'm in 10th grade, by the way. I need 35 points to qualify for INO, right?
Yeah, there is. You need to get about...
So 2 problems which are, 2 problems which are 200 points in total, right?
Yeah, 2 problems, 200 points in total. And INOI is 3 problems, 300 points.
Yeah, so if I'm able to see in an array and sort it and see it out, I should be able to solve enough subtasks to qualify for INOI, right? Just clarifying.
No,
sorry, I didn't understand. I couldn't comprehend what you said. Can you please repeat?
Yeah, sorry. Yeah, so
that if he can sort an array, he could just be selected for.
If I just solve 2 subtasks or 3 subtasks, maybe.
Historically speaking, yeah. Like I said, ZCO is pretty easy to qualify.
I did this last time. I did not get selected. I got like 15 points for doing subtask, and the cutoff was 16.
I mean, you got pretty close, right? That just says...
11th to 12th grade.
It is like, it's my experience. Get the full solution, please.
Yeah. Just clarifying. Thanks.
Okay, hold on.
Like if you're not able to do a problem, then it's a task. But make sure you find something of a full solution.
Okay, see, I'm gonna cover exactly this in some time, so you don't need to worry, guys. Yeah, more questions? People raising their hands?
By the way, I have doubt regarding the code forces div 3 and div 4. Are they basically ICPC style, or basically like in div 3 and div 4 their time does not matter, like there is not reduce in marks? per question. So it
Okay,
is
hold
like
on.
ICT mix.
Yeah, I'll
Can you
clarify
clarify?
that. I'll clarify that right now. Don't worry. Okay, so in code forces, a Div 3 and Div 4 contest generally follow. I think it's called a modified ICPC style. Over there, time does matter still. But the actual submissions don't have a score. You have this concept of like penalty time. I think the amount of time before you solve a problem is called your penalty time, and it's summed up for each problem. In Div 3 and Div 4 contests, you are going to have no like extra points for say solving G over A. So someone solving in not A B C D E F and solving only G will only get they will get the exact same points as someone only solving A. That's true for Div 3 and Div 4. By the way, the difficulty goes Div 3 is the easiest, Div 2 is like easier than that. Div 2 is like the regular difficulty, and Div 1 is the hardest. So there is actually also rating cutoffs. So I'm pretty sure it is 1200 or below for Div 4. I think 14, no, I think 1600 or below for Div 3, 1900 or below for Div 2, and above that is Div 1. Yeah. So that's Code Forces contests. By the way, for Div 2 and Div 1 contests, uh, it actually matters. Like they have a point distribution. So problem A may be worth, generally it's worth 500 points. Problem B is worth 1000 points. Problem C is worth like 1500 maybe or 1250. That depends per contest. By the way, this is also different from IOI, where every single problem is worth 100 full points. And as time passes in the Code Forces contest, the amount of points you get from a problem also decreases. So in the beginning, it would be 500. Say like 1 minute in, it would be 499. Then 5 minutes in, it would be 495. I'm pretty sure it's some linear function with regard to the amount of time that has passed since the beginning of the contest. And Div 1 is the hardest. Okay, so that's Code Forces. Yeah. Questions? I can see some people with
Yes.
raised hands. Yeah.
Hello,
Yeah. Hi.
audible? Do we have significant differences between 11th, 12th? Is there like a different system of cutoffs, or is it the same for everybody?
Oh, I don't worry. I was gonna cover this later on, but I'll just say in brief, it's different. But for any strong participant, I don't think it will make a difference. Like for Zetsio, in my opinion, it doesn't really make a difference. Technically, there is a difference. Girls have it a lot easier. Based on data.
Like 9 marks or something, no?
Hmm.
No, for girls it's like 9 marks or something, right, to qualify.
I think that was last year. Yeah.
Yeah. Oh, it changes every year, the cutoff.
It changes every year. Yeah, it depends on how people perform, not just. It's not an
All
absolute
right.
score. Yeah.
Hmm.
Okay, so Vinayak asked in chat what contests like Div 3, Div 2 for INOI. So I'm assuming you're asking whether you should give Div 3s or Div 2s for INOI. My advice would be Div 2s if you were to choose between the two. But like I said before, they are different types of contests. So INOI is IOI style, and Div 3, Div 2s are ICPC style. So there will actually be differences between contest strategy and stuff, or there should be, because I mean they're so different that it would be kind of weird to have this exact same strategy, right? So in fact, I mean, you should give like OI mocks to practice for INOI, in my opinion, instead of giving Code Forces. That's not to say Code Forces is bad or anything. Code Forces is really good at training like speed and contest pressure. So I mean, if you're not giving anything, then better give Code Forces than nothing. So yeah. Okay. Other people who have raised their hands, questions?
I have doubt regarding that. In CodeChef, like recently there are contests like starters 207, 208, like they're IOI style. So is it good for giving uh, the contest?
Okay, so I haven't actually seen what Coach Chef has. I'll have to check on that before giving a definitive answer. I'm not
Okay.
100% sure. Yeah, but generally speaking, I feel like, I mean, the best option over the board is going to be doing OI mocks. Okay. Yeah, Akshar.
I just had a doubt. Like before selecting our the center last year for the ZIO, the center was very bad and the calculators were not working
Oh, that sounds
in the system.
concerning.
In the systems, the calculator were not working. I don't know why. We had to do modulus 997, and I got this right answer, but the modulus was wrong.
Where do you live? Which center did you go to last time?
It was Nangloi, Delhi.
Delhi. Okay. So, uh, I don't have any control. But what you can do is you can mail Madhavan, sir. You should in fact mail him and tell him what exactly happened. And
Like it was, we complained a lot last year, but
nothing happened. It didn't change.
I don't know what will happen. But we complained. The center was horrendous, like dirty.
Oh my god, that sounds concerning. Um, okay, see, you mentioned this was a ZIO center, right?
No, it was ZIO. Yes,
Yeah, ZIO center, right?
ZIO.
So
Uh,
I feel like
ECS.
if you just grind for like I said, ZCO itself is really easy to qualify through. So I feel like if you just follow this lecture series and just put in a bit of effort, you'll be able to qualify through ZCO as well. So uh, I mean, you still give ZIO, but I think that there shouldn't be an issue because you'll be giving ZCO as well. But you should
No,
write to IRCS. That's the only way to get this rectified.
I will do, in fact, because this year ZIO is first and then it's ZCO.
Yeah, that's true. That's true. Okay. What are OMIOs? I said OI mocks, not OMIOs. That just means like contests such as like CEOI, POI. For INOI level, I mean NOI is like the best bet. Like, it's Singapore National Olympiad of Informatics. Yeah, those problems are like, in my opinion, the best to practice if you want to practice for INOI. But guys, don't worry, all of this will be covered. You don't need to stress out so much. ZIO centers usually not contracted through IARCS. Yeah, I'm not sure regarding the quality of ZIO centers, but like I said, the best thing you can do is probably just mail Madhavan. So okay. Anyway, guys, don't stress out so much. ZCO is genuinely doable. Okay, so you'll be fine. Yeah. Yes. Yeah. Yeah. Exactly. I already mentioned how there are no subtasks in code forces, right? You need to. So there are subtasks in OI problems. Now I keep mentioning subtasks. I mean, why do I keep mentioning subtasks? The reason I keep mentioning subtasks is because last year's ZCO cutoffs. I mean, I can just pull them up actually. Let me just get them on my screen. I'll just share my screen. Let me know if you guys can see it. Yeah, is my screen visible? Yeah. So this is from Samik's website, by the way. Credit where credit's due. He's in the meet right now. So, yeah. So as you can see, these are like last year's cutoffs. He's also just taken them directly from official sources. So all of this is like official. So for class 12 male, it was 28 out of 200 last year. Before that, it was 55 out of 200. In 2023, it was 27 out of 200. I mean, by the way, class 12 male is always the highest. That's why I'm just looking at that. So, you guys notice how every single one of these cutoffs is less than 100, right? Like, there is no cutoff here that's more than 100 points. So, that kind of says that, like, this is so different from code forces that you don't even need to AC a problem to qualify for INOI. So actually, one of the mistakes that a lot of people do when it comes to like OI is try to go for AC. It's not their fault, obviously. I mean, they're just not accustomed to the difference between ICPC and IOI style contests. But all I am saying is, should it be equal or greater than cutoff, or just greater? It's greater than or equal to, I'm pretty sure. Yeah, every one of them is Yeah, even these are greater than or equal to. Anyway, so like I was saying, you don't even need to solve a single problem fully. In fact, what your strategy should be is looking at the subtasks, trying to think about the subtasks, solving the subtasks. Like I am being serious. If you can get the full solve, then that's fine. I mean, then of course just get the full solve, but don't get stressed out if you can't, because I mean, as is evident, you don't need it full solve to qualify. Will you get an online judge in Zetsio? Yeah. So last year it was Codrills. It's this website. This website over here. This is what we used last year. So yeah, it's this website. I can just send it. So this website has like an online submission tool. You just like paste your code over there and you press submit, and it like submits it and it grades it for you. That's what's going to happen in Zetsio as well. And if my memory serves me right, I think you can also use it to compile and test your code on sample input, but I may be wrong about that. Yes, you are given a debugger. GDB is guaranteed to be installed on all of the machines, at least as per the standard specified on the website. Like they've specified that GDB will be installed on every single computer, so you are allowed a debugger. There's a problem to changing your OS to Linux. You don't have to do that. You don't have to use Linux on a day-to-day basis. I think every one of you guys will not face an issue with using VS Code or Sublime or whatever IDE you use in Zetsio or Linux, because it's very similar to using it on Windows. So you don't need to worry about that either. And by the way, I will compile. I mean, I will show you guys how to compile code and stuff as well, just in case you need help with that. As Zetsio is gonna happen in December, when would INOI occur? I mean, I don't think I can give like an authoritative answer, but I have a feeling it will occur in Feb around. But it won't clash with anything significant like board exams or anything. I mean, they always make sure that it doesn't clash. What IDEs were given in Zetsio? Again, if my memory serves me right, you could use VS Code, you could use Sublime Text. Yeah, it was like basically all the popular IDEs. Yeah, I think you could use code blocks too, but I will have to check. Yeah, you do have a choice. I think it is on the website itself. Samik, if you're here, can you just check and let them know what all IDs are there? Yeah, so code blocks and CLine apparently don't run that well on Ubuntu. So CLine especially, I know a lot of people who had trouble with that last year. But yeah, you can use most IDEs, like popular ones, so that's fine. Like I said, do not go for full solve. I mean, you can go for full solve. Do not go for full solve and don't get anything else in the process. What you should do, ideal contest strategy, should be read the subtasks. Look at subtask 1. Generally, it's going to be something like n equals 2 that you can like brute force or solve on paper. You should do that. And then once you do that, you're going to have an idea on how to proceed on the next one. See, the reason I'm telling you to do this is because, I mean, then you're going to qualify for sure. And I mean, once you do that, you can maybe then try full solving or doing whatever you want. Okay, so that's it for contest strategy. Now I'm going to cover some more important things. These are also like very important in terms of like how this stuff works. It's a basic concept, but maybe some people won't know it. So just out of curiosity, how many people here know or have heard the term time complexity before?
Oh yeah. Bigger notation.
Yeah, that stuff. How many people?
Yeah, I have heard it.
Okay, so that's great. It looks like a significant amount of people know about it. That's amazing. I'm still gonna cover it because, as promised, this is gonna be like a lecture for beginners, right? and I want to make sure everyone knows it. I don't want to assume stuff, but it's great to see that so many people already know it. Okay, so every oh, that's weird. I don't need to screen share anymore. So okay, yeah. Every single problem will come with a given input constraint. So let's say it's a problem like you're given two arrays, find the sum, pairwise sum of each element. They'll give you like the two arrays and they'll give you the size of the array, right? And the problem will specify like a maximum size. So in Codeforce's problems, it will be something like n less than or equal to 2 into 10 raised to 5 or n less than or equal to 10 raised to 4. You guys understand what I'm saying? Anyone here who doesn't, rather, is a bit confused by what I just said? So the long versus int thing I'll also cover later, but that's not exactly what I'm like asking right now. I'm just asking like, do you guys know what problem input constraints are? Hold on, let me just pull up a problem, just any problem, to show you an example. Doesn't have to be anything great. I mean, I'll just show you. I'll just pull up a random problem. Okay. Guys can see my screen, right? Yeah. So this is a problem, for example. It's from some recent Codeforces round. So this is the problem statement. It says there are n wizards numbered 1 to n. We don't care about that. All we care about is this. So it says that n over here, and that's the number of wizards, is always going to be less than or equal to 10 raised to 5. They always have an input section where they specify all constraints. So there's number of test cases less than or equal to 10 raised to 4. For each test case, this number n, like we didn't read the problem properly. We just saw its number of wizards, so but we don't really know what that means, but that's fine. All I want to say is that there is a number n which is given that is less than or equal to 10 raised to 5. Then they're given n numbers which are all less than or equal to n as well. So this is what I mean by constraints, and this line is also important. This over here is what I mean by input constraints. So what I said before is that every single problem will come with input constraints. Okay. So now I hope everyone understood. What those are. Okay. So now what is time complexity? Time complexity in general is it's just something that describes how your number of operations you perform or how much the execution time of your program scales with the size of the input. So I mean, suppose you had a program that worked for like an array of size 10. It's pretty natural to assume that it will work faster for smaller arrays, and let's say at n equals 20 it will be slightly slower, and at n equals 2000 it will be even slower, right? So time complexity is just something that gives you like an approximate function that says that okay, it will be slower, but it will be this much slower. Okay, so does anyone have, I mean, I haven't fully explained it, but so far does anyone have any doubts about what time complexity means? No one here? It's fine if you do, because I'm asking because I'm not sure if I explained it properly. No one here? Okay, great. So then that's good. Formally speaking, number of operations versus time complexity. Okay, so this comes under the definition of time complexity. Basically, if you let T of n denote the number of operations, then you can say that the time complexity of your algorithm is O of f of n. Okay, so it will be a function if and only if there exist numbers c and n naught greater than or equal to 0 such that T of n is less than or equal to c times f of n for all n greater than or equal to n naught. So what I just said right now is like a really fancy way of saying that basically if I say that my time complexity is O of n, the O of, I haven't told you guys what that is yet, but let's say I said my time complexity is O of n, that means that there will exist a number, a constant number c, like we can take it as like 100, and I'm guaranteeing that the number of operations I will perform is always less than or equal to 100n, where n is the number given to me as input. If I can say this, then I would say that the time complexity of my code is O of n. So this is like very theoretical. I don't, maybe like a lot of people might be confused. This is why I'm now going to show code snippets regarding time complexity. Because I think examples will always like clear stuff up the best, right? So you guys can see my screen, I hope. Number of operations c times n. The number of operations in this case is t of n. C times n, c times f of n is the upper bound on the number of operations, so it's always less than or equal to that. But anyway, we are going to start with this. I'm just gonna zoom it in so it's readable. Yeah. Okay. So this code over here, it takes in a number n. Sin is what takes in a number, and it creates an array. Vector is just another word for array of size n, and then it fills that array with numbers from it fills it with n numbers. After that, it prints those n numbers immediately after. If you like want the Python equivalent, it would kind of be like a is a list for I in range n. I think it's a dot. I'm not too sure though, because I don't know Python that well, but it's gonna be something like this, and then something like that. I hope the pseudocode was understandable. So this thing has a loop of size n, a loop that runs n times, and another loop that runs n times. So any guesses to what the time complexity of this code should be?
O of n.
Yeah, exactly. It's O of n.
Often.
The reason it's O of n is it's called append. Okay, cool. I see. Well, I'm happy that you understood anyway, because I'm not that great at Python. But yeah, anyway, so this is O of n. The reason is because it actually performs like, let's see, one operation, one operation if you count initialization of the integer as an operation, taking in a number, creating a vector that's like 3, then this is n, so this 3 plus n, another n operations, that is 3 plus 2n. By the way, I'm just being approximate here, but we approximately calculated the like 3 plus 2n operations, right? So if I say O of n, that's basically like me saying, hey, I can always bound the number of operations by some function of n. So I'm saying f of n is equal to, in this case, it's going to be 3n. Or let's take 5n just to be safe. Or like if n is equal to 1, then this will perform 5 operations. That's more than 3 plus 2. If n is equal to 2, it will perform 10, which is also more than 3 plus 2. So this acts as like an upper bound for the like worst case some number of operations we'll perform. The time complexity of this code is O of n. Okay, is it working slightly now? Okay, great. Okay, sorry about that. I don't know why that happened, but yeah. So what is ON? By the way, I'm not using STD because you should, ideally speaking, be using namespace STD because it speeds you up during contest. I just wrote this now, so that's the reason I didn't use it. But yeah, there's nothing wrong with using it. That's just a matter of style. So lower bound over here is binary search. If you don't know what that is, that's fine. I will just tell you that this over here is O of log n per step. Okay, that's like, I'm telling you, this takes log n operations. Using that information, can anyone over here guess what the time complexity of this code will be?
N log n,
Yeah.
O of n log n.
Yeah, it's O of n log n. The reason it's O of n log n is because you have n things you're doing, and in each of them you are doing log n amount of work. And so, of course, like log n repeated n times is just n into log of n, right? So this is O of n log n. By the way, you don't need to know what lower bound means. I just put it as like a thing because it's like an actual example. We will be covering all of this in future lectures, so even if you don't know it, that's perfectly fine. Let's look at another example. Wait, this is the same example. Oh, all right. Yeah, let's look at this example. This one is also pretty interesting. Yeah, so any guesses as to what the time complexity of this code is? Yeah, it is n square, that's correct. The reason it's n square, you have an inner loop over here. This thing is doing n operations, right? Because we're looping from, we're looping from 1 to from 0 to n minus 1. So this is n operations by itself. But then the n operations is repeated another n times. So in total, we are doing n operations n times, and n times n is n square. That's the reason this is O of n square. I think my voice may have lagged again. Sorry, did you guys hear what I said properly or no? Or should I repeat? Okay, great, it was audible. Okay, cool. Yeah. So this is O of n square. What about this code? I mean, this I feel like even people who know some stuff may struggle with. Although maybe not. I don't know. It's like not that usual, you know, in terms of like these kind of analyses. Is C the time it takes to perform only one operation? Okay, so I can't even read the code since I haven't learned C++. Okay, hold on. That's perfectly fine, by the way. You don't need to be able to read and understand exactly what the code does. You just need to like get the vibe of it, honestly. Like if you want, I can go over the previous examples with like pseudocode in Python. Would that help? Or do you think it is fine? By the way, the correct answer for this is what Shyam said, yeah. It is O of n into 2 raised to n. Yeah. You got the other ones, okay, yeah. So this one is a little trickier than those, yeah. I agree. So the reason it's O of n into 2 raised to, yeah, I know, that's what I meant, right? The reason this one is O of n into 2 raised to n is because, wait, hold on. Yeah, it's just getting the vibe. You don't need to. The reason I'm showing you all of these like complex codes right now is because I want you to be familiar with like C++ syntax even before you like get into like actually learning it. So, I mean, once you see it for real, you know, then you'll just be like, oh, okay, I've seen this before. You know, hey, that code looks similar to this. You don't need to exactly understand everything that's going on right now. Yeah, so this code over here, I mean, this thing over here, one shifted left n. I think Samik said it in chat already, but this is like the same thing as saying 2 to the power of n. So if you know this, then there's this one loop that iterates 2 to the power of n times, another loop that iterates n times. In total, how much work are you doing? You're doing n operations 2 to the n times. So you're doing n into 2 to the n. So the time complexity is n into 2 to the n. Yes, it is a bit shift. It is a bit shift. So shifting by n means you're multiplying by 2 n times. That's why it is 2 raised to n. Zareen asked how much C++ is needed for competitions, the general syntax plus operations, or do you need to know advanced syntax and methods? You don't need to know advanced syntax. The C++ you'll need for CP is very, very elementary, so you don't need to worry. I mean, so you'll need to know this one shifted n thing, but I have a feeling that's like one of the most complex things you will need, relatively speaking. So this is technically called a left shift. The reason it's called a left shift is because like these arrows point to the left, right? Like if you draw an arrow like this thing points to the left, right? Basically, look, all you need to know about 1 shifted left n is that this is equivalent to saying 1 into 2 raised to n. That's all you need to know. And by the way, like I said, don't need to understand the code entirely. You just need to understand the time complexity part. So 1 shifted right n would actually do, I think it would make the input 0 because, let me actually do a better example. 4 shifted right 1 would be equal to 2. So 4 shifted right 1 would divide by 2. 4 shifted left 1 would be equal to 8. So I hope now you understand what's going on. 3 shifted right, 3 shifted left by 2 would be equal to 12. Another example. I think I saw some more questions. Any books you'd recommend? Yeah, the what Samik said is very appropriate. That's like a pretty good book. I think it's the only actual book I would recommend. Otherwise, I would tell you to not use books because doing CP from books, in my opinion, is a bit flawed. It's flawed because like you can burn out really fast if you use books. But yeah, CPH is like the one exception to that. Something that I would actually recommend. Yeah, problems are more fun. Yeah. CP3 by Stephen Hallam. I'm not sure. I'll have to check. So I can't comment on it because I'm not sure what about that book. Yeah, algorithm design is very overkill for learning CP. Like and it will already sorry, it will burn you out. Like this Yusuko book by Darren Yaugur. So about these books, see, I can't give a definitive answer on which books are good or not because I haven't heard about these books before. The only book I have heard about and the one that I would endorse is CPH, which Samik already mentioned. Otherwise, I would recommend you don't learn from books. Platforms that you use, don't worry, I'll get to that. You don't need to worry. I think we have some more examples regarding time complexity. Now that you guys have seen that one, this one should be pretty easy. Any guesses? What's the time complexity of this code? Yeah, everyone's saying 2 raised to n. That is correct. Yeah, it is 2 raised to n. So the reason it's 2 raised to n this time is because you don't have O of n work being done here. We're just printing the mask once. That's O of 1 work, right? That's just one operation. That's why. And over here we're doing O of n work before doing the O of 2 to the n work over here. So we're not doing O of n work per operation. We're doing O of n work first, and then we're doing O of 2 to the n work. So the dominant factor here would be the 2 to the n. Great, actually, this reminds me, I forgot to cover this, but if you have something like O to the 2 to the n plus n, people generally just write this as O to the 2 to the n of O of 2 to the n because as n approaches infinity, 2 to the n grows a lot faster than n. So it's like the more dominant factor, so you can say that it's like more dominant. Even like if you had something like O of n square plus 2n, you would write this as O of n square. You would just kind of neglect the 2n. Because what really matters is that you have a bottleneck of n square here. The 2n compared to the n square isn't going to slow down your code as much. Yeah, you always choose the greater one, exactly. You always choose the greater one. Whichever one has the most effect, like the highest effect, you always choose that one. Actually, let's just go back to this example. Over here, I'm doing O of n work per thing. Let's say I change this just for once to I plus 1 over here. What would happen? I mean, it looks like it's like more complicated now, right? What's going on? But actually, if you think about it a bit, you'll just realize that this is actually 0 plus 1 plus 2 plus 3 plus 4 plus n minus 1, and this is the same thing as n, or it's n minus 1 into n divided by 2, and this is the same thing as n square minus n divided by 2, which is the same thing as n square by 2 minus n by 2. And like I just said, in time complexity, we don't care about the less influencing term, we only care about this, so it still remains O of n square. I'm just going to change this back to what it was before. I hope this made sense though. So I mean, the general heuristic is that if you have two nested loops, then by the way, this is not always true. You have to specifically count the number of operations. But the general heuristic is that if you have two like kind of independent loops, the time complexity is just going to be multiplying how many times each loop runs individually. Like, by the way, it's important that the loops have to truly be independent of each other. Like some cases that in some cases that's not going to be true. In these cases, it is true. I think the first examples are pretty. Oh no, the first examples are new things. Okay, yeah. So this code, I mean, people new to C++ again wouldn't have seen this before. But I think you can still kind of infer what the time complexity would be. So give it a try. What do you think the time complexity of this code is going to be? Yeah, let's see. N factorial. Okay, one person said n factorial, and n factorial is correct. Yeah, I'll explain it. Don't worry. I just wanted to see how many people could just get it. But yeah, of course, I am going to explain it. Don't worry. So what this code does is, it basically you don't even need to understand this do while whatever. All you really need to look at is, oh my god, there's while. You know, we know while loops are a thing. And then there's this like mysterious line that's std next permutation a dot begin a dot end, right? So next permutation, what does the array begin as? It begins as a of I is equal to I. So let's say n is equal to 10, then, or let's take a smaller case, n is equal to 5, then it would be 0 1 2 3 4, right? Then there's some function called next permutation that is called, and for each thing we just do this. We do like one for loop which linear scans over a. So how many permutations are there in an array of distinct elements of size n? So really this is just like a basic combinatorics question, right? Yeah, it's basic PNC. The answer is n factorial. So since there are n factorial possible combinations, this thing is going to loop over all of the n factorial possibilities. So this loop is going to do O of n factorial work. Now this inner loop, for each one of those n factorial things, what we're doing is we're again looping over a. What's the length of a? The length of a is n, right? So we're doing an additional work of n of n per loop of n factorial. So in total we are doing O of n into n factorial work. So, and that is the time complexity of this code. Hope that's clear, right, everyone? Lectures will be
What is
daily,
the
weekly.
what is the and I notation for? Int and what ampersand.
This means reference. I mean, even if I omitted it, in this case, nothing would really change. So you don't need to worry about it.
Okay.
I can remove it and it would be the exact same. We are gonna cover references and stuff when we cover C++. This is just an intro, so you don't need to worry about it for now.
And what did next permutation do again? I didn't get it.
So did you get that it would run n factorial times? I didn't actually say what next permutation would do. I mean, now that you asked, I'll explain it. But basically, all I said before is that it will run n factorial times. What next permutation does
Yeah.
is it basically takes this permutation, whatever is there so far, and it transforms this to form the next lexicographically occurring permutation across all of them. So if I call next permutation on this, I'll just write it in pseudocode. This would be equal to 0, 1, 2, 4, 3, because lexically speaking, this is the next one that comes.
Yes. Oh, right. Yes. Yeah.
Yeah. And if once this reaches 43210, what's gonna happen is there's no next permutation, right? This is like the quote unquote last permutation. So the loop is just going to terminate because this is going to return false. And when there is a next permutation, it returns true. So the loop continues.
And what does the inner loop do? Like x plus equal to I.
I mean, I guess it adds all of the elements of the permutation to a variable x. Technically speaking, you could also do n factorial into sum of a. Like that would also work. It will give the same output, right? But
Yeah.
you could do that. But basically, what's important right now is that it does O of n work per inner loop.
Okay. Yes. Get it.
Yeah. Okay. Cool. That's why in total it's n into n factorial. And now let's move on to the final example, which is also like really similar. So what would the time complexity of this be? I think this one's going to be pretty easy now if you guys understood the previous one. Is x the count? Where is x? Oh, x is just a random variable. It doesn't matter. I just introduced it so the code actually does something. Doesn't have to. No, it's not the same. It's not the same. It's slightly different. I'll just pull up the previous code again, and this is the previous one. This is the current one. It's not the same. So this one, the only difference here is that there is no inner loop. Like, there's no inner loop. So the O of n work we are doing per permutation before, we're no longer doing that work anymore. So the time complexity is just going to be the number of permutations, which is O of n factorial. Yeah.
I'm assuming x plus equal to a naught just like adds the first term of the permutation each time.
Yeah, that's exactly what it does. Yeah. Okay. Could I try rejoining real quick? Why is my voice cracking or something? Okay, hold on. Wait, I don't think I can rejoin. Should I try refreshing the page? Yeah, exactly.
This meeting is being recorded.
Okay, hopefully that should be better. Okay, so now that we have covered time complexity, we can move on to space complexity. Now, space complexity is virtually identical conceptually to time complexity. The only difference is instead of measuring the number of operations, we're going to be measuring the amount of space we use. So every problem you solve will also come with like a number, like it will say like, oh, you're given n less than or equal to 10 raised to 5, right? Maybe you'll need to take in n numbers as input and process them. That will require to store n numbers simultaneously in memory, right? So it's often useful to estimate how much memory like your program uses. Like an int, for example, uses like 4 bytes. So an array of n integers would need around 4n bytes. Right? Like you doing these rough calculations can help you like understand how much memory your code is using. Actually, let me open that exact same code forces problem again, just to show you. Yeah. So there's time limit per test, that's 2 seconds, and there's also a memory limit per test of 256 megabytes. So space complexity just measures this. Time complexity helps with this. So space and memory kind of the same thing, right? However, generally speaking, memory is almost never the bottleneck when it comes to like Olympiad style problems. Like, of course, there are going to be some exceptions, but like as a general rule of thumb, you'll mostly need to care about the time complexity of your code. In fact, most of the time you end up trading time complexity for space complexity by changing your algorithm or how it behaves in some way. So I still think it's important to mention what space complexity is, but I don't think you guys will need to worry about it too much, at least for now. Okay. So I already
And how do
mentioned.
we know like here it's written time limit in seconds. So how do you compare like time limit to say the complexity or
Oh,
O of n?
perfect question. Actually, that was exactly what I was going to cover right now. Yeah, great. So the thing that most people do, useful heuristic is that you can fit around 10 to the 8 operations in 1 second. So let's say you had n less than or equal to 10 raised to 5. You could like realistically expect to be able to iterate over the array like exactly 1000 times. Not exactly, but approximately 1000 times, because that would be 10 raised to 8 operations in 1 second. Okay, so of course, I like I just said, this is like a heuristic, right? I mean, there's this thing that like not all operations take the same amount of time. Like for example, doing a simple bitwise XOR is going to be very cheap as compared to doing like a multiplication, or a division is even worse actually, or modulus is like even slower. You don't need to actually keep all of this in mind. I mean, maybe you should, but that doesn't mean like, oh, stop using modulus, because I mean you still need to use it. What I just mean is that the 10 raised to 8 is a heuristic for the reasons I'm just saying, that not all operations take up the same amount of like time. So in some cases, like you're not always going to like the 10 raised to 8 rule isn't like always going to be applicable. Some judges are like slightly slower, like for example, I think in IOITC the graders they have are like a bit slower than the graders on like Codeforces or other places, for example. So in those cases, you kind of just have to know, and you will know, so don't worry too much. You kind of just have to know like what grader is going to be used and stuff, roughly speaking. And if the grader is slower, it's like safer to assume that you can do around 10 raised to 7 operations. So it's like every single person either uses 10 raised to 8 or 10 raised to 7. I personally use 10 raised to 8. So yeah. Okay, one more thing that I've actually seen beginners make mistakes with. I mean, I've mentioned this already, but this n less than or equal to 10 raised to 5, they might just see this and be like, okay, cool, who cares, you know? I'm like, I'll just solve the problem. Who cares what n is, or if it's less than or equal to 10 raised to 5? It's there for a reason. It's not a random number. It hints at the expected time complexity of your code. So, for example, in n less than or equal to 10 raised to 5, you already know right off the bat that n square won't pass. The reason we know this is because n square is 10 raised to 10, and that is more than 10 raised to 8. 100 times more, in fact. And according to our approximation, it would take around 100 seconds to run, but time limit is only 2. So we're a lot slower than we need to be. Right. Some problems have n less than or equal to 5000. In that case, n square is actually reasonable. Somehow 500. In that case, n cube is generally what's intended. Some problems even have n less than or equal to 20. In that case, you generally need O of 2 to the n. Like the mask thing I just did. This, yeah. You either do this or you do something like this, where you have a loop and you iterate over all possible bit masks. So that's all possible combinations from 0 to 2 raised to n. If it's something really massive, let's say they gave you something like n less than or equal to 10 raised to 9 or 10 raised to 18, then the only real option you have is to use something like O of log n or O of 1. Because even O of n in that case would be 10 raised to 9 operations, and time limit is again 2 seconds, right? So that would be 10 seconds, but you only have 2. So that itself would be too slow. Okay, so basically the lesson is this is not a random number. Please read constraints before thinking of solutions. Okay, one more important thing is would n log n work in that Cape's question? Yeah, n log n would work. I'm not sure. I think my solution, actually, let's not get into that. I think mine was either O of n or O of n log n. But yeah, n log n will work here, O of n would work here, and anything better than that would also work. Anyway, one more very important thing is I just gave you this entire speech about 10 raised to 8 operations, 1 second, and you come out of it thinking, oh great, and let's say I gave you 2 algorithms. One had a time complexity of O of n square, another one also had a time complexity of O of n square, and you're gonna think that both of them are basically the same, right? I mean, maybe theoretically they are, but one of them, they may not necessarily be the same. It is very well possible that you have a slow n square algorithm, quote unquote slow n square algorithm, and a fast n square algorithm. Depends on the particulars of the question and the code in question. But let's say I had something that was looping over the array, with, let me pull up that example real quick. Let's say I was doing this exact same thing, but I added another loop over here. Yeah, let's say I just added another loop. So if you notice, the time complexity of this algorithm actually hasn't changed at all. Why has it not changed? Because 10 is a constant, right? So it would actually be 10 into n square, but 10 into n square according to time complexity is the exact same thing as n square. So this is still n square, but I mean, anyone who actually thinks about it, you'll be wait, wouldn't we expect this to run around 10 times slower because it's doing the same thing 10 times instead of just doing it once? So the thing is that they aren't the same, right? So there can be quote unquote fast n square and quote unquote slow n square. Constant factors matter a lot when it comes to competitive programming. You don't only need to code let's say you have a question with 10 raised to 5 or 5 into 10 raised to 5. You need to not only code an n log n, it also needs to be a fast and efficient n log n, just in case you don't TLE. One example for people who maybe have been doing C++ already. Again, if you haven't done C++ yet, you don't need to worry. All of this will be explained in future lectures. But I'm just going to mention it now just in case. And maybe then again, when I teach it later, you'll think, oh, he mentioned this before, a very common example is unordered map versus map. So STD unordered map has a theoretical time complexity of O of 1 per access. But STD map is O of log n per access. Despite this, unordered maps are very, very prone to being hacked, and they are generally very slow as compared to regular maps. So in this case, this is one practical example where O of 1 is actually worse than O of log n. So basically my point is time complexity isn't everything, and while it can be a very useful tool, like it's like one of the most important things, that's why I covered it for so long. It's like it can be a very useful tool, but it's not everything. So you need to be careful about that too. Okay, now does O of 1 mean only one operation? O of 1 doesn't mean only one operation, it means a constant number of operations. The reason it means a constant number of operations is because if we go back to the definition, this would mean that f of n is equal to 1, right? But we just said that t of n has to be greater than or equal to c times f of n. So it's greater than or equal to c, where c is a constant, right? So that means a constant number of operations. So it can be 100, it can be 10, it can be 5. All that matters is that it doesn't depend on the input size. So let's say I make n 1000 and it was 100 before. I would still do 10 operations, or I would still do 20 operations, or how many ever I was doing. That's what O of 1 means. Lectures will be weekly. Every week until ZCO we're going to have a lecture. Okay, so now that I've covered all of like the theoretical stuff, I'm going to cover something that's important in like actual code. So I showed you guys like how many examples was this? Let me just have a look. There were like 8 examples that I showed you guys, right? I think 7 because one was like a duplicate. So in all of these, I have this like one bits C++ thing at the top. I have my int main, and then I have these like 2 lines of code. What do these 2 lines of code do? You know, why do I have them at the beginning of every single one of my solutions? Like every single one of them, it's like I would just like invariably put it over there. So what exactly does this do? So what this does is, and if you're using C++, you should, generally speaking, always include these at the beginning of your solution too. These speed up your input and output. So these statements, the printing statements and the taking and input statements, by around 2 to 3 times. And the exact mechanics by which it does this, I think would be a bit out of scope. So I'm not going to cover that. But all you should know is that this speeds up your input and output by around 2 to 3 times. And for every problem that is not interactive, you should always include this at the beginning of your C++ solutions. I mean, it's fine if you just memorize these 2 lines, but this is like a very common bottleneck. Like it's a, like even people who are good make this mistake. Like people write like correct solutions, but then they forget to add these 2 lines at the beginning of their main function, and they TLE. Like their code doesn't run in time, and then after the contest they realize, oh my god, I forgot fast IO. Fast IO is these 2 lines, by the way. So please remember these lines and always write them at the start of any non-interactive problem. And in future lectures we will actually cover, you know, what this does, but I still think it's a good idea to like memorize these 2 lines. Okay, that's one thing. Second thing you may have noticed, again, people who don't know C++ wouldn't really understand, but I've used this thing called \n here. I haven't used this std end line thing. Now again, is there a reason for that, or was that just an arbitrary choice? I mean, from the
I know the reason. I don't know the reason. Basically, in this handle operation, like it does a flush operation, so like it has a worst. It has not good time complexity
Yeah.
compared to \n.
Well, time complexity wouldn't be the right word, I guess, but yeah, it's slower. That's definitely what you meant to say, and you're right. It is slower by a lot. That's exactly correct. I mean, your answer was correct. This \n over here doesn't flush the output buffer stream. This does. For people who don't know what that means, don't really worry about it. All I would say is you just always use \n, never use std end line, other than if you have an interactive problem. Like notice how I said you include these 2 lines if you don't have an interactive problem. You use \n instead of end line if you don't have an interactive problem. Okay, so in those cases it will always help you. For interactive problems, don't listen to this. Then just do whatever you're gonna do normally. Okay. In contests, maybe you will not get like the correct solution right away. You know, these problems are like, they're unique in the form that, like, I mean, we are holding like a lecture like we're holding a lecture series for ZCO, right? Which means we're obviously going to be covering like commonly done topics and everything, and like the most important things, right? Oh, it will end. It's basically like done. I think there's like only like I think I have like only like 5 or 10 minutes worth of things to say, and it's basically done. Length of each session will depend on the actual session content itself, but I would estimate around maybe 1.5 hours per session, or it could be even more than that. A faster I/O is mostly beneficial for big integers. It's beneficial for any question where you're doing a lot of input taking. So let's say n less than or equal to 10 raised to 5, it will be beneficial, but I mean not that much maybe. I mean, if you had n less than or equal to 5 into 10 raised to 5 on the other hand, then you would basically be shooting yourself in the foot if you didn't include fast I/O. That's why I said you should definitely include all of those lines every single time. I believe I have good notes and analysis. Yeah, there's no worries. You can share it, definitely. What are platforms for learning and university admissions based on OI? Okay, so it's actually pretty simple. INOI gold medalists have quote unquote special consideration as per said on the website. That's what's said on the website for NUS. They are like pretty much guaranteed admission to CMI, and IIT Gandhinagar, there's like 99% chances that you'll get in as as an INOI silver or gold medalist based on historical data. Like, I mean, this is just like what's happening, like, right now. Yeah, like, yeah. So now, like he mentioned, IIT Kanpur and Madras have also started stuff, but it's a lot more restricted than IIT Gandhinagar. As in, a lot of people get into IIT Gandhinagar through OI. IIT Madras, I think, only has 1 or 2 seats, and I think they are also split across all Olympiads, not just IOI. Yeah, 1 seat for males, 1 seat for females across all Olympiads. So Madras is really hard. Kanpur, on the other hand, is 3 seats for IOI people, and I don't know if they have a seat for males or a seat for females. For IIT Gandhinagar, the direct admission is pretty much actually direct. For the other IITs, they don't even promise direct admission. For CMI, it is genuinely direct admission. Like, there's no real questions asked at all. For NUS, you have to have a lot of additional stuff on top of Olympiads. By the way, I saw someone ask, like, will interactive problems come in OI? They won't come in ZCO, or at least historically speaking, I don't think they have in the 2 ZCOs that I've given. But they can come, and they will come in IOITC problems if you get to IOITC, and they will definitely come in IOI as well. And sometimes Code Forces ask them as well. How did you guys explain to your parents about OI and stuff? Yeah, that's actually, it's kind of a good question, given this session is about, like, meta questions to begin with. I don't even remember what I did. Honestly, I feel like they didn't really understand until I made IOITC, and after I made IOITC, they understood. So I mean, it's gonna be the same thing for you guys. They'll start taking it seriously once you actually show them that, holy shit, I'm doing stuff. So that's all fine. I did CSCS intro problems. What to do next? See, again, this lecture is mainly just an introduction to competitive programming. We are going to have lectures that will dive at topics. Like, actually, the next lecture is going to have like a problem set with, like, I think like 7 to 8 problems related to what we actually lecture about, that like we're gonna make you guys solve. And honestly speaking, at least for ZCO, I can say that if you like attend every single lecture and solve, not even every single problem, if you solve 50% of the problems we send, you are 100% qualifying through ZCO. So you can calm down. It's all fine. How do you get the will to type out the code once you figure out the logic? I just get lazy and skip it. And that comes under like persistence. That's honestly, I don't know. I think this would come under implementation skills, right? And contest mentality. Again, for ZCO this won't matter much, but for like INOI and IOITC, especially INOI, it will matter a lot. You need to be able to code stuff fast. I mean, this lecture honestly was kind of an ask me anything only. Like it's an intro lecture, so it's fine. So I mean, this question, you definitely need to practice implementing stuff fast, and overcoming that laziness. Like I cannot stress how important this is. Maybe not for ZCO, but for INOI. So I would say start doing it right now. Now that you got into IOITC, are you neglecting JE? Yeah, I'm not doing JE. I'm just focusing on my 12th grade boards and hopefully getting into IOI next year. So yeah. I think that's pretty much it. I don't know if I have anything else to cover. Yeah, no, that's pretty much it. Okay, so I mean, final words I have to say, like, I'm sure everyone here, has at least, like, if you're attending this lecture, you know what competitive programming is. If you know what competitive programming is, you have tried to code stuff before, and I'm pretty sure it will be, like, very overwhelming. There's, like, so many YouTube channels to watch from, so many resources to learn from. There's, like, so much you can do, and it's, like, always, like, so unclear what you're supposed to do, I mean, I can say this, like, from personal experience, because even I've literally been in the same shoes, even I've been confused about what to do and stuff, because there's just so much, and it's very different from anything else. So I just want to say that that's normal. You don't need to rush, okay? You just need to calm down. You can focus on, like, doing something over nothing, and you will almost certainly make progress. You just need to like, relax a bit and trust that when you put in effort, you get results from the effort you put in. That's honestly, like, you just have to trust yourself. In terms of actually doing contests, also don't rush. You need to focus on them being correct first, speed later. Need to learn to reason about problems as well. Like, you need to learn to, like, take out paper, write down stuff, and think hard about what's going on. Over time, the problems will get easier. Like, you'll start solving div to b's, div to a's, like, basically instantly, because the patterns, you'll just recognize them. And when the questions that felt impossible are going to be, like, easy questions. So that's all you really need to know to get started. I think I've covered everything important. So yeah. Welcome to competitive programming, everyone. I hope you guys like your time here and find this meaningful. Not needed to prove solutions, by the way. In contests, definitely shouldn't, because it takes up time, and you need to be fast. But if it's about correctness, then, like, if you're not convinced it's correct, then you should maybe try proving it. Yeah. So that's the end of the lecture. Unless anyone has more questions, I'll just answer those, and then we can just wrap this up. Thank you everyone for attending, by the way. I appreciate it. And I hope everyone found this helpful too. So next week we're going to have another lecture. This time it's going to be on an actual competitive programming topic, instead of just like a general overview of what it is, which is what this lecture was. So, and we're also going to give you problems with that one. So again, I would recommend everyone who's first doing ZCO to attend pretty much every single lecture. But yeah, I mean, it was my idea to hold, like, this one, like, intro lecture before we actually start teaching stuff. I think it was a good idea. I think this went pretty well. So yeah, anyway, I hope you guys enjoyed. Yeah. That's it from me. Okay, bye.